So, so now we stopped around question number 6. So, so we finished until question number 6 in structure 2030. Second question. A part. So we'll be continuing with the rest. Right now we see the seventh question. What would you observe when a green colored aqueous solution of CrCl3 is subjected to the following? First one, addition of few drops of dilute NaOH. So they are what is observation for the green color? They have given the colors also, so no need to worry. So for seventh question. So once you have CrCl3 aqueous solution, so when you add NaOH aqueous state, there is going to be an observation. So once you add a few drop of NaOH to this CrCl3 aqueous solution, there is going to be a precipitate formation. So precipitate can be observed. So CrCl3 doesn't have the ability to dissolve excessively in NaOH. So therefore, it will remain as precipitate, right? So therefore, what kind of color precipitate we can obtain is green color precipitate. So green color precipitate, is obtained. So this is the observation. So for extra type, like what is the chemical formula of green color precipitate? If they ask, so it is here. No, it's thrice. Sorry. So this is the observation. So green color precipitate can be seen. That is the answer for the 7% first one. Right? 7% first one. Now see the second one. Addition of excess dilute NaOH followed by H2O2 and then heated. Right. So what you are going to do is you are going to add some amount of NaOH. Excess dilute NaOH. Right? You are going to put excess dilute NaOH. So as a result, what will happen? You will get the same thing. So you see a precipitate. Right? So CrCl3 aqueous solution color. So CrCl3 aqueous solution color is aqueous solution color. CrCl3 aqueous solution color is green color solution. So most of the fluorides are aqueous in solution except for AgCl, PbCl, Hg2Cl2, CuCl. All those are they form precipitates with chloride ions, right? So except them, others all can form clear aqueous solutions here. So they have colors. So in that case, CrCl3 forms green color solution. So once you add excess NaOH with some amount of H2O2, what will happen to the solution is this CrCl3, this Cr3 plus, it will oxidize to what? It will oxidize to CrO4 2 minus. CrO4 2 minus. And H2O2 in a sense will be reduced to H2O. So Cr3 plus. Once it offers CrO4 2 minus, here the color change can be observed. Over here, you can see color change. You cannot see any precipitates here. No precipitate can be found, but you can see color change. So Cr3 is already green in color. It turns to yellow color. It turns to yellow color. Okay. Now see here. Sorry, there was a call. Right. So the green colored solution, due to the oxidization from Cr3 plus to CrO4 minus, there's going to be a color change. When green colored solution turns to yellow colored solution. Right? These are main reasons. So under basic medium, under the basic medium, this process takes place. So this process takes place in basic medium because we're using OX minus, which is from NaOH. We're using excess dilute NaOH. So if the medium is going to be basic, so as a result, once you add Cr3 plus and CrO4 minus, I mean Cr3 plus with H2O, you will get CrO4 minus H2O. So as a result, the solution is going to be yellow color, right? So this is the observation. So in the observation, you can see the green colored solution. The green colored solution turns to yellow color solution. So this is the observation. So this is the observation that we found by adding excess dilute NaOH along with hydrogen peroxide, right? So you can say this reaction is D. Another point. So this one is called the identification test. Identification test of Cr3 plus. So this is there at the last page of the resource book. So the last page of the resource book, you have the points here. So there they use this medium, right? So as a result, this is the formation here, right? So take the points, what have we got from this? Right. Now let's go to the other question. Let's go to the 8th question. Yeah. Now see, when a concentrated solution of potassium dichromate, okay. So now we have a concentrated potassium dichromate solution now. Okay. So potassium dichromate's characteristics that must be known. So potassium dichromate is a very strong oxidizing agent, and the color of this, so the color of this solution, right? The color of this solution is orange in color. This orange color, right? So these are the 2 points we need to know. So very strong oxidizing agent. So once potassium dichromate, concentrated solution of potassium dichromate is treated with concentrated H2SO4. Concentrated H2SO4. Once you add concentrated H2SO4. The bright red acidic oxide of X of oxide X of chromium is precipitate. The bright red acidic oxide of chromium is precipitate. So bright red acidic oxide. Underline the word bright red acidic oxide. So there's going to be a bright red acidic oxide. So there's a bright red precipitate. Bright red acidic oxide. So bright red acidic oxide. So on heating, so this is X. So on heating, the green color amphoteric oxide Y is obtained. So once you heat this, once you heat this, you're gonna get Y, which is an amphoteric green color oxide. Amphoteric green color oxide. Right? So here from bright red acid oxide, that is X, which under heating goes to amphoteric green color oxide. Right? So they are giving another point. Y, which means this, Y also could also be obtained on heating on ammonium dichromate. So ammonium dichromate. So once you heat this, right, you need to know the products. Once you heat this ammonium dichromate, you need to know the products. What is there in this? What will be produced during the decomposition of ammonium dichromate. So this was asked in 2023. Question number 25, 25 or 26. MCQ. So last year, right? So keep in mind. So when ammonium dichromate is decomposed, first and foremost you will get the green colored oxide. Plus you will get H2O, that which is in gaseous form, because I'm heating them up. At the same time, we're going to get into gas here. So we're going to get nitrogen gas, dichromate, and then we're going to get H2O. So these are the products that you can get from ammonium dichromate. So ammonium dichromate can give uh, amphoteric oxide. So this is the amphoteric oxide they're talking about. So what is the color of chromium oxide is? It is green color. Green color. So since it's a green color oxide plus they said this is amphoteric. So this one should be sure in CrO3, Cr2O3. So that must be the first clue. So we have amphoteric people, but that is not in this category. According to the question. According to the question, it's not based over here. So once you see that, right? Once you see that, you will get an idea here, right? You get a good idea over here. Now see bright red acidic oxide. So first thing we asked you online bright red acidic oxide. So it is an oxide here. So you are using con H2SO4, right? Con H2SO4. So in this case, so accordingly, See here, this is the thing. So by heating, right? By heating this compound, we found out that this is going to be the chromium oxide here. So important oxide green color. So once you take chromium, so in chromium's oxidation state, in chromium's oxidation state, we have +3, which is M43. Then we have +2. Then we have +6. Okay. In +6, we have 3 forms. Keep in mind, we have 3 forms actually. One is really unstable. One is really unstable. So we have 3 types. So one is CrO3, sorry, then CrO2 minus, and we have Cr2O7 2 minus. These two people are aqueous. It means they're in liquid form. These two people are in liquid form, while this is an oxide here. This is an oxide. So this one's color widely ranges it like around, you can say, nearly red, right? Since the question they said bright red, you can consider this. They said it is an acidic oxide. So if you see the oxidation number, you have +2, +3, and +6 here. So this is M40. As I said in the previous video, once you increase the oxidation number, the acidity will increase. So this is going to be the acidic oxidation number here. Once you go below the amphoteric oxidation number, it is going to be basic. So this particular product is unstable. So this is quite unstable at room temperature. It will break. This is quite unstable, maybe. It is unstable. These two are stable at room temperature, right? So CrO3, it is a bright red acidic oxide. So the question is like, give the chemical formula of X and Y. So what you can say for X? So X is CrO3, and Y is an amphoteric green oxide, Cr2O3. So this is the answer for it, right? Yeah. Right. Now see the next question. What would you observe when dilute NaOH is added to a solution of potassium dichromate? An interesting question here. An interesting question. It's an interesting question here. So see here. Now we're going to add basic oxide here. Right? We're going to add a basic oxide here. Now see, you should know, as I said, there are two different compounds formed in the same oxide, right? That's what I have talked about. So these two people, right? These two people, we will say this one, this is potassium, this is bromine, this one is dichromate. This chromate and dichromate ion. So the color of this compound, This one is yellow. This one is orange color. The solutions are quite different, right? So this is yellow in color, this is orange in color. So you can identify them in this aspect. So these two people form an equilibrium between them. They form an equilibrium between them. So if you write their balanced equation, once you write the balanced equation, let's say first thing for acidic medium. So for acidic medium, see here guys. So CrO for 2 minus, right? CrO will have an equilibrium with Cr2O7. 2 minus is normal case. So if you balance this out, So see here. Now what I'm going to do is, now using the red pen, I will explain you. Now what I'm going to do is, now I'm going to add some H plus here. Let's say I'm going to put some amount of HCl here. Now to this case, I'm going to add some HCl here. So once I'm in HCl, now there's a rule called by Lee-Chatelier principle. So there was a rule discovered by the scientist called Lee-Chatelier, a French scientist. So he proposed that now since now this is an equilibrium reaction, so this system is not disturbed yet. So it is in equilibrium, right? So it is in equilibrium. So once you add some amount of HCl, so H plus is going to be added here. So once you add some amount of HCl, so I'm going to increase the amount of HCl. So the system will be disturbed here. The total system will be disturbed here because you're going to add some amount of HCl, H plus here. So as a result, let's say instead of equilibrium reaction, let's say format. So by adding H plus here, the chromate will tend to move towards the dichromate state, right? The chromate, once you add acidic medium, once you add H plus, it moves to the dichromate side. So therefore, this one's color initially was yellow. One's initial color was yellow, but once you add H plus, once you add H plus to the solution, this yellow color solution turns finally to orange color. So if you find the oxidation state change, the oxidation states are going to be the same. So here if it is plus 6, this also going to be plus 6. There's not going to be a change, but the color change will be observed. You can observe the color change. So it turns yellow to orange. So in the same case, if you can apply this to acidic medium and to the basic medium, if you can apply this to the basic medium, apply this to the basic medium. So let me balance this using the basic medium here. So it comes like H2O plus 2 CrO4 minus removing this way. So Cr2O7 2 minus plus OH minus. So what I'm going to do is now I'm going to add some amount of OH minus. I'm going to add some base. Let's say NaOH. I'm going to add some amount of NaOH to the solution. So here, once I add NaOH, this Cr2O7 tends to move towards the CrO2 minus. Once I add NaOH in solution, Cr2O7 tend to move towards the CrO2 minus. Right? The reason is because for both the cases, here chromate is unstable because chromate is unstable in acidic medium. Since this fellow is acidic, this fellow is unstable in acidic medium, it tends to move to the dichromate side. Once you consider here, the reason is because Cr2O7 2 minus is unstable in basic medium. So it's unstable in basic medium. So therefore, what will happen? They'll move here to there. So if you add base here, this orange color will go towards will go towards the chromate. So chromate's color, which is yellow color, it turns from orange to yellow. So what is the question they have asked? What would you observe when dilute NaOH is added to potassium dichromate? So keep in mind, once you add NaOH, you will see a color change. That orange turns to yellow. Why it happened? Because dichromate changed to chromate. So orange will turn to yellow because dichromate changed to chromate. So they have asked observations. What is the observation? The orange color solution. Turns yellow color. Orange color solution turns yellow color. So this is the answer for the question number 9. Right? This is the answer for the question number 9. Right. Now see here, give one advantage and one disadvantage of using potassium dichromate in titration. Right. Now they are asking an advantage. They are asking for an advantage and a disadvantage of using potassium dichromate in titration. So let's talk first about the advantage. That's the normal thing now. Usually we talk about advantages rather than disadvantages. It's like you become motivated by positive, you become weak by talking about negative. So in that case, so first we'll talk about these good things. So dichromate. So dichromate is especially used as a primary standard for titration, especially for the halides. For the identification of halides, we use potassium dichromate in the titration process. So since this is very strong oxidizing agent, this can be used to oxidize certain halogens, like halides. Like for example, if you take chlorine in the presence of chloride ions, you can use this one for the titration purposes. So that is the main advantage. So So the answer is titration can be done in the presence of chloride ions. So they ask one, so you can refer them up. So we see disadvantages. Take the disadvantage. So what is the disadvantage? Like for example, I can give a good example. Now see the cases here. So acidic medium and the basic medium. Let's say now we are going to do this process, particular process in basic medium. Right? Now we're going to use potassium dichromate and with one more reducing agent to do a titration. So you know already the color of dichromate. So dichromate color is orange color. Right? So dichromate color is orange color. So since you're going to use basic medium, this dichromate won't stay stable for a few seconds. So what will happen? If you add Na, all of a sudden this orange color will turn to yellow. It will move suddenly to yellow. It will keep turning to yellow. Once you keep adding drop by drop of NaOH, all of a sudden it will go to yellow color. So as a result, what will happen? The indicator change will be there. So you cannot use that particular flow as an indicator. It is not a suitable self-indicator. Understood? Since it doesn't go as an indicator, this is going to be a huge disadvantage. Even though if you have the advantage here, there's going to be a disadvantage also. Understood? By doing the questions in the chemical calculation side and all, we consider that only the indicators. For example, like phenolphthalein, methyl orange, bromothymol blue, methyl red, all those people, all those indicators are going to give the color change, except the other people. We take them, all of them as clear solutions. But in the fact of experiment, once you use potassium dichromate, you cannot use it as a self-indicator because of this problem. You can use it in acidic medium, no problem, no harm. But once you're using it for basic medium, you're going to get a problem here because orange will turn suddenly to yellow. As a result, this particular compound, Cr2O7, will move to CrO4 minus. So therefore, the disadvantage is not suitable for self-indicator. So this is the answer for the 10th one. So advantages of dichromate, disadvantages of dichromate. So this is the structure part of inorganic essay. So we'll continue this one in the next class, right? So as I had some error within the PC, so I had to stop the recording. So this is the today's recording for the inorganic chemistry structure discussion of 2013.